imaging. So, by the end of the session, we will understand the concepts that are making a real difference in diagnosis and patient care. So, let us enter into the topic. So, thank you one and all for joining the session, which is a part of the fourth international FDP organized by SKRGC Academy. Our focus is on how AI and Python are revolutionizing medical diagnostics. I'll guide you through the basics, introduce you to the essential tools, and share a real world example. My aim is to empower you, whether you are a teacher, researcher, or practitioner, to bring these innovations into your own work. So, first, moving on to the importance of AI in medical imaging. So, AI is a game changer in medical imaging. Traditionally, radiologists had to manually review images, which is time consuming and sometimes prone to error. AI can analyze images much faster and often more accurately, so helping to identify tumors in MRI scans or detect pneumonia in X rays. So, this not only speeds up diagnosis but also allows the radiologist to focus on more complex cases while AI handles the routine ones, reducing errors and improving patient outcomes. So next is understanding key terminology. So before entering into the topic, so we need to know the basic terminologies with respect to AI and machine learning. So first of all, what is AI? AI or artificial intelligence is when machines mimic human intelligence. So that is AI, and machine learning is a type of AI where computers learn from data, improving over time. And deep learning is nothing but the subset of ML. Okay, that uses layered neural networks. These are especially good at analyzing images. So deep learning is very good and suitable for analyzing the images. And in medical imaging, we use AI for three main tasks. So one is classification, segmentation, and detection. So classification is used for sorting images as healthy or diseased one. So whether the from the images we can identify whether it is the image of a healthy person or a diseased person. And segmentation, which means it's not only with respect to person, it can be a plant disease or any kind of thing. Next is with respect to segmentation, which means outlining specific areas like tumors. And detection is which is about finding and marking the abnormalities present in an image. So next is Python tools for medical imaging. So what are the various Python tools we have so that we can use it for medical imaging? So Python is the most popular language for AI in medical imaging because it's actually easy to learn and has powerful libraries. So the libraries in Python are very, very useful for us. And if we come to know about the libraries, and we can use it in a very good manner in order to extract data. So NumPy and Pandas has helped us to organize and process the data. And OpenCV is used for reading and manipulating the images. So next is scikit-learn is great for traditional machine learning algorithms. So with respect to traditional machine learning, we can go for Scikit. And TensorFlow, Keras, PyTorch are used to build deep learning models, and the Nibabel for handling medical images. So and in medical images format like DICOM and Nifty, which are common in hospitals. So these are the standard formats which are used in hospitals. So next comes the medical imaging modalities. Understanding different types of medical images is crucial for applying AI. So we have different kinds of images, that is X-ray and the computed tomography, MRI, ultrasound, PET, and so on. So X-rays are nothing but it gives us quick and good for bones and chest exams. So by using X-rays, we can just get the quick information about the bones and the chest exams. And CT scans, that is computed tomography, it provides a cross sectional, it gives a cross sectional image so doctors can see the inside organs, internal organs, that is. So MRI is nothing but the magnetic resonance imaging. It gives a detailed image of the soft tissues like the brain, spinal cord, and so on. So next is ultrasound. It's actually safe and widely used for pregnancy and soft tissue examination. Next is a positron emission. It shows how tissues are functioning, which is useful for the cancer diagnosis. So each type of image needs its own pre-processing and AI approaches. So we have different kinds of images, different types of images, and then we are going to use different kinds of pre-processing techniques in order to work with the images. So next is moving on with the pre-processing techniques. So what is pre-processing techniques? So pre-processing techniques are nothing but so before we use the images have to be uh, pre-processed. That is, it has to be converted into a form so that it is suitable for processing. That is, we need to improve the quality and consistency of the images, because the images what we receive, the images what is obtained from the data set may not be consistent or anything. So we have to improve the quality and consistency. So the different techniques what we are going to use in order to while pre-processing them is normalization, so resizing, noise reduction, contrast enhancement, and histogram equalization. So coming to normalization. So what is normalization means? It's used to adjust the pixels so all the images are on the same scale. So all the images, so each images might be of different sizes or different scales. So normalization technique, when it is applied to the images in the data set, it just brings all the images to a common scale. So noise reduction is removing the unwanted noise from the images. So so it removes the unwanted artifact that could confuse a model. Next is resizing. Resizing is to make all the images to a same dimensions. Next is contrast and enhancement. So it makes key features stand out. So that is, the key features are projected out. So we can get the important features of an image. So next comes the histogram equalization. It improves the visibility of structures in an image. So good pre-processing is essential for building accurate AI models. So any combinations of them or several of them can be taken in order to pre-process the image. So next, coming to a small snippet of pre-processing technique. So here we use OpenCV to load the image in the grayscale. So we can import the things, import CV2, the NumPy, and then we read the images. So after reading the images are resized and normalized. So we use OpenCV to load the image in grayscale, resize it to a standard size, and then normalize the pixel values. So these steps make sure our images are clean and consistent, which is crucial for training deep learning models. So actually, this is very important for training deep learning models. This is the first step. Pre-processing is the first step, which is very important that for training the models. So this is a foundation for any AI project in medical imaging. So each and every step has to be chosen in proper way, and the first step is the pre-processing. So that we have seen now. So the next is deep learning in imaging. So what is deep learning in imaging? So deep learning, especially using convolutional neural network. So CNN, so convolutional neural network, commonly called as CNN, has revolutionized the medical imaging. So it has transformed the medical imaging. So in what way it has transformed means it can automatically learn to recognize the patterns in images from simple edges to complex features like tumors. So advanced models like UNet are designed for segmentation, so which means they can outline the exact boundaries of organs or abnormalities. So by using CNN, so we can easily recognize the patterns in the images. Easily recognize the pattern. It can be a simple edge or to a complex structure. Anything it can be. So it can be useful for finding, recognizing and finding out the problems present in the images. That is, with respect to tumors also, it can be found out. So we too have advanced models like UNet. So where this unit is used means it is used for segmentation purpose. So what is called a segmentation means they can outline the exact boundaries of the organs or abnormalities. So exact boundaries are marked and given. So it saves time and improve accuracy, making it easier for doctors to diagnose and treat the patient. So doctors can use these predictions so found from these models, and they automatically it just gives the exact details and exact thing. So it helps the doctors in diagnosing and the treating the patients. So the next is the CNN architecture overview. So a typical CNN, that is convolutional neural network for medical imaging, consisting of several layers. So it consists of convolutional layers first, activation functions, pooling layers, fully connected layers, softmax, and sigmoid output. So the convolutional layers use filters. So different layers are there in convolutional neural networks. So neural networks can have any number of layers in some pattern. So depending upon the output, so these layers can be improvised. So here we are having the convolutional layer. It uses filters to extract the features from the images. So by using convolutional layer, we are extracting the features. So features from the images are extracted by using convolutional layers, and we are using filters for this purpose. So next is the activation function. So what is activation function? We are in activation function is used to introduce the non-linearity to the model. That is, it helps to learn the model and learn the complex pattern. So activation function, example of an activation function is ReLU. So ReLU helps a model learn the complex patterns. So that is the purpose of activation function. Next, coming to the pooling layers, it reduces size of data, so making the model faster and less likely to overfitting. So next is the fully connected layers. So fully connected layers combine all the features for the final decision. So based on this, the final decision is taken. It combines all the features for either classification or regression. So the output layer gives a probability for each class, that is whether the image depicts a tumor or not. So likewise. So the number and types of layer depend on how complex the task is. So a CNN convolutional neural network can have any number of convolutional layers, and the layers how they are being chosen and the filters. So how the convolutional layers and the filters are chosen, the number of layers and filters depends upon the complexity of the task and data. So it is actually used to extract the features. So it depends upon how complex the data is. Depending upon it, the number of layers also increases. So next comes the unit architecture for medical image segmentation. So this is one of the advanced one. So unit is a special deep learning model designed for segmenting medical images. So it has a U-shaped structure with a contracting path on the left that captures features by reducing the image size, and an expanding path on the right that restores the image size for precise localization. So UNIT is a special deep learning model. So UNIT is used for segmentation purpose, and so actually there is a contracting path and the expanding path. So two things are there. It is a U-shaped structure. UNIT architecture is a U-shaped structure. It has contracting path on the left side, and that captures the features by reducing the image size. So, and on expanding path on the right, it restores the image size for precise localization. So, this is how it is structured. And then comes the skip connections. It is widely used for tasks like outlining tumors or organs in MRI and CT scans, making it a vital tool in modern medical imaging. So it's actually highly effective and widely used for tasks like outlining tumors or organs in MRI and CT scans. So actually now it plays a very important role in modern imaging, modern medical imaging. So next comes the transfer learning in medical imaging. So transfer learning in medical imaging, we often have small data sets. So data sets means we do have a lot of data sets available in internet. So data sets consist of collection of data. The data can be in the form of images or it can be in the form of CSV files. So we can get the data and we can process the data. So these data sets, actually the medical imaging data sets, coming to the medical imaging data sets, so they are small in number compared to the other type of problems, so making it hard to train the deep networks from the scratch. So what happens is transfer learning solves this by using models that have already learned from a large data sets like ImageNet. So learning is one kind of method that helps us to work with images or work with data sets which has less images, since medical images are less in number in the data set. So we use the concept of transfer learning. So it solves this by using the models that have already learned from the large data sets like ImageNet. So we keep most of the pre-trained model and retrain only the last few layers on our medical images. So this approach saves time, needs less data, and usually gives better results. So actually, where it is used means especially useful for tasks like detecting diabetic retinopathy or pneumonia in X-rays. So these are the places where this transfer learning concept is being used. Next comes the evaluation metrics in medical imaging. So actually, accuracy is very important. So whenever we talk about metrics, the first word that comes to our mind is accuracy. So apart from accuracy, but it is actually not enough in healthcare. So accuracy alone is not enough in healthcare. So we need to know how many of our positive predictions were correct and how many actual cases we caught. So these things have to be calculated. So knowing how many of our positive predictions are correct, so that is called as precision. So how many of our positive predictions are correct, so that gives us the precision value. And how many actual cases we caught, so how many cases we have caught, that gives the recall or sensitivity. So and the F1 score balances these two. So, coming to the evaluation metrics, accuracy plays an important role. And apart from accuracy, we need to focus on the precision, the recall, and the F1 score, which balances these two. So, the next comes the ROC measure. So, it measures the model's ability to distinguish between the classes at various thresholds. So, it measures how well the model distinguish between classes at different thresholds. So next is for segmentation, we use IOC or dice coefficient. So that is IOU and dice coefficient is there. So for segmentation kind of things, we use that one to compare the predicted and actual regions. So in those places, we will be using IOC or dice coefficient. So using these metrics, we can ensure our model are safe and effective for clinical use. So next is here we are going to discuss about the commonly used data sets in medical imaging. So as already discussed, so data sets are nothing but a storehouse or a collection of data. So we can get the data sets available. It's available in the internet, and several images are present in the data set in the form of CSV or image files also. So public data sets, so they are called as public data sets and are essential for developing and testing the AI models. So first comes the one of the data set is the chest X-ray 14. So over 1 lakh chest X-rays labeled for 14 different kinds of diseases. So next is a BRATS, which provides MRI scans for brain tumor segmentation, and ISIC is another data set. Skin lesion, it contains skin lesion images for melanoma detection. So each and every data sets consist of images of for different kind contains different images, so which can be used for training the models and using it for our purpose. Next is the LIDC IDRI, which offers CT scans for lung nodule analysis, And next is the drive and stare have retinal images for diabetic retinopathy. These datasets actually help their researchers benchmark their models and compare their results. So different kinds of datasets are there. So depending upon their necessity, so the researchers can use the datasets from these, can use the images from these datasets and do their research works. So next comes the pre-processing. Here once again we have a real example from Python. So this time for a brain MRI image. So last time we saw about a program for pre-processing. Same way, this is also a pre-processing for a brain MRI image. So any kind of image. So the first thing is to read the image. So we import this file and then we read the image. And the next step is to resize the image. So we load the image in grayscale, resize it to 256 by 256 pixel and normalize the pixel values. So why we write it as image 256 comma 256 means we are resizing and normalizing the pixel value. So for second line is for resizing. First we are reading the image, next we are resizing the image, and the third one is to normalize the image. So once normalizing, other common steps include denoising to remove the unwanted noise, histogram equalization to remove to improve the contrast, and masking to focus on the important regions. So all these steps help ensure our data is clean and ready for AI analysis. So it depends upon the images. So what kind of pre-processing things we are going to choose, it depends upon the images. So we can use any combinations of these in order to pre-process the image. So next comes the model building using TensorFlow or Keras. So this is a simple convolutional neural network model for binary classification, and that is to differentiate whether the given image has a tumor or non-tumor. So the given image is based on a image of a patient. So from this program, it is able to analyze. So this model extracts the features from the images and analyzes whether the person, the final layer, actually the final layer uses a sigmoid activation for binary classifications and find out whether the image is a image of a tumor or a non-tumor. So coming to the program, we start with a convolutional layer to extract the features. So add a pooling layer to reduce the size. So we have the convolutional layer to extract the size. Then max pooling is there. So pooling layer is used to reduce the size. Then we are flattening the data. After flattening the data, we use dense layers for learning the complex patterns. So the purpose of adding the dense layer is to learn the patterns, and the final layer is sigmoid. The second dense is a sigmoid. So it's actually an activation function for binary classification. So here we have the two things, that is classification is either between a tumor or non-tumor. So it's actually a binary classification. So here we are using the activation as sigmoid. So this structure is a foundation for many medical imaging applications. So this is a model building using TensorFlow and Keras. So the next comes the visualization techniques, GradCam and heat maps. So it after finding out whether the person has a tumor or not, with respect to medical imaging, it is important to uh, bring it out in the output. So we need some visualization tools to bring the output. So that is very important here. So we use this GradCam and heat maps here. So it is important to understand why an AI model makes a certain prediction, especially in healthcare. So the GradCam is a technique that highlights a region in the image that influence the model's decision. So it just highlights the region and says why the model has found out. For example, if the model has found out the image is expected to have tumor, it means it will point out the region uh, why it is influenced, why it has taken the decision. It points out the region and then it gives the reason. It's like a justification. So that is with respect to GradCam. So for example, if a model predicts pneumonia, so it can show whether this GradCam can show whether it is focused on the lungs or not. Okay. So this is with respect to GradCam. So next is heat map overlays these region onto the original image, making the model's reasoning transparent and building trust with clinicians. So these visualization tools are really helpful and just ensure whether the prediction made by the model is correct or not. Next, with respect to a case study, that is the brain tumor segmentation. So let's look at the real world example brain tumor segmentation using the Brat's data set and a unit model. So the model was trained to identify and outline different tumor regions in MRI scans. So achieving a dice score of 0.85, which means it was very accurate. So here, so the data set chosen is Brat's data set. So data set chosen is Brat's data. Model is a unit model, and so to segment brain tumors from the MRI scan. So this is the task, and the model was trained to identify and outline different tumor regions in MRI scans. So the model is trained. The model is already trained to find out the tumors, to identify the tumors, and it was able to achieve a score that is the dice score of 0.85, which means it was very accurate. So if the model achieved 0.85, it means the model produced accurate results. So the process included pre-processing, data augmentation, training the unit, and post-processing to refine the results. Such automation helps doctor plan treatments and monitor tumor changes over time. So what happens is the workflow included pre-processing, as already discussed. What is pre-processing? It is just tuning the images, or just we are cleaning the images before it is trained by the model. So data augmentation is to increase the number of images in the data set. So how we do augmentation? So either we can do rotation, reflection, or uh, so any kind of these methods can be used in order to improve the number of images present in the data set. So then model training. So training the model and post processing. So the next is the post processing to refine the results. So these automation. So since it is an automated one, so it helps the doctors, it helps the radiologist to find out or to plan the treatment and to monitor the tumor progression or the changes that takes place in the course of time. So next is a case study with respect to diabetic retinopathy detection. So first one we saw about the brain tumor segmentation, and next is about the diabetic retinopathy detection. So another example is detecting diabetic retinopathy from retinal images using the deep learning model actually. So the model was based on Inception v3 and fine-tuned on Aptos dataset. So the dataset used is Aptos, and the model was based on or built based on Inception v3. So it is used to detect diabetic retinopathy. So this is with respect to the model and the dataset and what it is used to detect. So as usual, any model, it first undergoes the pre-processing steps. It included color normalization and vessel extraction to enhance the features. So we extract the images. So we extract in order to find the or highlight the important features. So then followed by data augmentation. So in order to increase the number of images. So here they have mentioned increasing the diversity of training images. So by using data augmentation, we can increase the number of images and the diversity of images. That is, for example, if we give the images or take the images in different directions or different rotations, so each image can produce another different set of images. So that is with respect to augmentation. So it increased the diversity of training images. So the number of images trained can be increased by using it, and the model achieved got that is 94% sensitivity and was deployed in mobile clinics, enabling early detection and treatment even in remote areas. So the case study involved diabetic retinopathy detection. So it used the Aptos data set, and the model was based on Inception V3. So it followed the data pre-processing, that is pre-processing techniques. Augmentation was used, and this model developed was able to give an accuracy or sensitivity of 94 percentage, and really it was very useful, and treatment also. So even in remote areas, it found out to be working well. So next is moving on with the edge AI and mobile deployment. So AI models can be optimized for portable devices to provide real-time diagnosis. So where we can use these AI models means for usage in portable devices to provide real-time diagnosis. So in real time, how we are going to use? We can use tools like TF Lite and Onyx, convert the models to lightweight formats. So the tools are converting the models to lightweight formats, and devices like Jetson Nano, Raspberry Pi, and smartphones can run these models effectively. So there are some tools in order to convert the models into lightweight formats, and the devices like the Jetson Nano, Raspberry Pi, and smartphones. So by using smartphones itself, we can run these models effectively. So the deep learning models can be run successfully in the mobiles. So this approach brings AI powered diagnostics to location with remote with limited resources, improving healthcare access in rural or that is underserved areas. So in those areas also it will be very useful. So when we are using these AI models in portable devices, so these devices are helpful in predicting the diseases. So initially it is developed for few cases, so later it may be improvised for several other things. So AI in radiology workflow automation. So how AI is used there. So actually AI is designed to assist, not replace the radiologist. So this point has to be made clear. So it is actually is helpful for the radiologist. It is made to it's designed to assist and not to replace the radiologist. It can automatically pre-screen the scans, the flag the abnormal cases for further review, prioritize the emergency cases, and generate the reports, the preliminary reports using natural language processing. So integration with the PACS, that is a picture archiving and communication system. So ensure seamless workflow and adoption in clinical settings. So this partnership between the AI and radiologists lead to better and faster patient care. So by using this AI in radiology, it is not that it is replacing the radiologist. So when AI combines with radiologist, it is used to treat the patients at a greater care, and it can generate the reports, and it can save the radiologist time, and it is helpful a lot for them. So next comes the difference between the segmentation, classification, and detection. So it is important for us to understand the different tasks in medical imaging. So what are the various tasks that are present in medical imaging is the segmentation, classification, and detection. So coming to classification, so it determines if a disease is present, like detecting COVID-19 in X-rays. So that is called as classification. So finding out whether it is present. So that next comes the segmentation. So what is segmentation? It outlines the exact boundary of structures such as tumors or organs. So segmentation is used to it is used to outline the boundary of a structure, which is different from the normal one, whether it is a tumor or organ or any kind of thing. Okay. So next is the detection. So it locates and mark the object, like drawing bounding boxes around lung nodules. So detection locates and mark objects. So it is used to mark the bounding boxes. So different tasks, each task require different model architectures. VGG can be used for classification, UNET can be used for segmentation, and YOLO for detection. So likewise, so the different works, okay, the different tasks in medical imaging, that is we have the classification is a task, and segmentation is a task, and detection is a task. So each of these tasks we can use different kinds of model architecture, And sample example is VGG can be used for classification purpose, and unit can be used for segmentation, and YOLO can be used for detection. So next comes the handling class imbalance in medical data. So the medical data set often have many more normal cases than diseased cases, leading to class imbalance. So here the medical data sets, so the data sets which are the public data sets which are available, so they don't have the even number of things. So there is a class imbalance. So for example, if we are having 1000 images, the 500 images can be a normal one and 500 can be a disease one. So it is a balanced one, but actually the data sets are not balanced, it is imbalanced. So when we are training the model with these imbalanced one, we cannot assure the model is going to produce the correct result. So if not handled properly, the model may become biased and miss rare but important cases. So if we are not training the model with the proper cases, so we won't be getting the correct output. We won't be getting the correct one. So the model will become biased and miss rare and important cases also. So solution includes oversampling the minority class using SMART to create synthetic examples, assigning class weights in the loss function, and using focal loss to focus on hard to classify cases. So these techniques helps to ensure the model pay attention to all types of cases and not just the common ones. So the oversampling the minority class or using SMART. SMART can use to balance the data. That is, SMART is nothing but synthetic minority oversampling technique. So it assigns class weight in the loss function and ensures the model paid more attention to rare cases. So the rare cases are paid more attention so that no cases are or nothing is left out and the model is not biased. So and we have another technique called the focal loss. Focal loss is another technique. So to focus on hard to classify cases. So it's another technique that focuses learning on hard to classify examples, and so it is used for these techniques helps ensure the model pay attention to all the cases, not only for common case. It just works for all the cases. Next is AI for COVID-19 diagnosis from CT or X-rays. So during the COVID-19, everyone who would still remember the COVID-19 pandemic. So during the COVID-19 pandemic, AI played a key role in rapid diagnosis actually. So CNN models were trained to detect this COVID-19 from the chest X-rays and CT scans. So from the X-rays and CT scans, it was able to detect. So the CNN models were able to detect whether the patient has or that is the X-rays. X-rays depicts the person whether they are having COVID-19 or not. So transfer learning and ensemble models methods improved accuracy actually. So transfer learning was used in order to improve the accuracy. And these AI tools provided fast, scalable screening, especially where traditional tests were slow or unavailable. So the traditional test is nothing but the RT-PCR testing, which was slow or unavailable at that time. So this AI helped the hospital triage patients and manage resources more effectively during the crisis. So the next comes the role of GAN. So the role of GAN is nothing but the generative adversarial networks. So now we are going to see the role of the generative adversarial networks in data augmentation. So this GAN are used to create synthetic medical images. So these are used to create synthetic medical images for data augmentation. Already I have told data augmentation is used to increase the number of images present in the data set using either different techniques like rotation, reflection, and so on. So the GAN helps increase the amount of training data, especially for rare diseases. So when the data images, that is the images are increased, especially for rare diseases, they generate realistic images that make models more robust and less likely to overfit. So applications include synthesizing new MRI scans or retinal images for training. So this approach is especially valuable when collecting real data is difficult or expensive. So when we can use this type of thing is when collecting the images so becomes tough, this approach is going to work a lot. This approach is going to help. So next is the model deployment with Flask and Streamlit. So once the model is trained, so it needs to be accessible to users. So we do pre-processing, we collect the data from the data set, and then we pre-process the data. After pre-processing the data, uh, so the next is to train the model. So develop the model, train the model, and to use it. So once the model is trained, it is need to be accessible to users. So it's a what is Flask? Flask is a lightweight web framework that can turn your model into a web API. So Streamlit allows you to quickly build interactive web apps where users can upload the images, get predictions, and download the reports. So these tools make AI models easy to use for clinicians and researchers, even if they don't have a programming background. So these things are used when people without any programming background also can use it. The clinicians or the researchers, it is not necessary that they should have programming knowledge in order to use these models. So once these models are trained, they can so either Flask or Streamlit can be used. Or Flask is nothing but the lightweight web framework that can turn your model into a web API. So it can be converted into the programming interface. So next, what is meant by Streamlit means it allows you to build interactive web apps where user can upload the images, get predictions, and download the report. So what they can do, just they can upload the thing to through the app. So in the app, they can upload the images, doctor's prescription, or the images of the scanned report or anything. They can uh, upload the images and they can get the predictions and download the report. So that is the purpose of having this Streamlit. So just give the report and get the suggestion. So how we use, for example, we use AI tools now. For example, we can say that Chat GPT also. So we can upload anything and we can try to get or the idea about what kind of image it is or the explanations. Likewise, same way we can get it through Streamlit also. But this is different, and the Streamlit is different, and ChatGPT is different. But for understanding purpose, I have related these two. So these tools make AI models easy to use for clinicians and researchers, even if they don't have a programming background. So integration with hospital information systems. So for AI to be truly useful in healthcare, it must work with existing hospital systems. So AI output should connect with electronic health record. That is, we usually call it as EHR. So doctors can see all patients' data in one place. So compatibility with DICOM and HL7 standards ensure smooth communication with hospital imaging equipment, and embedding AI directly into the software streamlines workflow and support clinical decisions. So this integration is key to making AI part of everyday medical practice. So all these tools are going to help us a lot, help each and every one to ensure that how AI is very important and how AI is highly bonded with the medical practice, and how it can be used in a real world or in day-to-day life. So we have a lot of AI tools. Uh, so output should connect with EHR for seamless patient data management. So we also have the various standards for smooth communication with the hospital imaging equipments. So next is moving on with the regulatory framework and safety. So AI in healthcare actually must follow strict regulation to ensure safety and privacy. So the data has to be kept safety and it also to be maintained private. So in the US, models must be cleared by the FDA. In Europe, they require CE marking. So the models must be cleared. So the models, when they are developed, so it has to pass through FDA. In USA, they have the thing called the checking called FDA. So the models must be cleared by FDA, and in Europe, they require CE marking to ensure that their models are providing safety and security. That is the patient's data, everything has to be protected, everything has to be private. So it should not be available for everyone. So patient data privacy is protected under laws like HIPAA. Okay. So models must be transparent, traceable, and reproducible to gain regulatory approval and clinician trust. So following these rules is essential for safe and ethical AI deployment in medicine. So these rules have to be followed. Then only we can say that actually it's a safe one, and it is a safe and security, and it provides a privacy for the patient's data. So coming to the future trends in AI for medical imaging. So the future of AI in medical imaging is very exciting actually. The foundation models like BioGPT and MedPalm can process multiple types of data such as images and text. So we have various models like BioGPT and MedPalm. And as I already discussed, so the images, medical images are of different types, like it can be images also, or it can be in the form of text or CSV files. So these models can process any kind of data. So, and the multimodal fusion combines image data with clinical records for more comprehensive analysis. And the federated learning allow the model to be trained across multiple hospitals without sharing sensitive data and protecting privacy. So this is the benefit of federated learning. It allows model to be trained. So the model can be trained across multiple hospitals, but the data of the patients will not be shared. So self-supervised learning reduces the need for large labeled dataset, making AI development faster and more scalable. So the purpose of self-supervised learning is it reduces the need for large labeled datasets. So so actually, in the beginning, we expected that a large number of data. So the data sets are available, but the data sets are not available with huge number of images and so on. So because of this self-supervised learning, that problem comes to a thing. So it becomes a solution for that problem. Self-supervised learning, it makes AI even more powerful and accessible in healthcare. So with this, we have completed with our today's session. And so as we wrap up, if you have any questions.
Thank you, ma'am. Any queries from faculties? Any queries? Ma'am. Yeah, okay, ma'am. Thank you, ma'am.
Thank you, ma'am.
Good evening to all. As we conclude today's session, Fourth International Faculty Development Program, I take this opportunity to extend our heartfelt thanks to our esteemed resource persons, Ms. Loganayagi, ma'am. Thank you, ma'am. And I also thank all the resource person for past 4 days. We are grateful for your time, expertise, and contributions, ma'am. A special thanks to all the participants. Thank you all. Thank you once again, ma'am.
Thank you, ma'am. I thank you for giving me this opportunity for doing the presentation. Thank you, one and all, ma'am.